In this video, we are going to discuss about how to interface an LED with the ESP32 module. So this is the block diagram of a ESP32 module where you will see there are a number of GPIO pins, and using one of the GPIO pins we are going to connect the LED, interface the LED with this device. So here GPIO2, it has this module has an inbuilt GPIO, LED, inbuilt LED, which is interfaced with GPIO2 pin, which is the fourth pin here. So we are going to turn on and off this LED using the Arduino programming. For that, we are going to open Arduino Cloud software, where you can do everything in online. So Arduino Cloud, you just have to create an account in this website so that you can log in and start doing projects. So I'm clicking get started, where it will take you to the home page of your Arduino Cloud. Okay, so you can write your codes in this. You can develop your own applications. You have the web editor to edit the program or create new programs using this new sketch. You can also create multiple dashboards that you want to monitor. For example, if you connect a sensor to your device and you want to visualize the sensor values, you can use this dashboard to visualize the sensor data. So I'm just going to my dashboards. Again, I think it will be asking me for sign in. Okay, it is already signed in. Now it is time for us to start a new project. Okay, so for the experiment that I have told, we just need an LED and we want to turn on or off. So for which I need one digital variable, so that I am going to create. And this Arduino IoT Cloud has several features in which you can see things, dashboards and devices. The device is your physical device, and this things is your virtual device. So here whatever the variable you are going to use, that will be automatically configured in your physical device. Okay, and then the dashboard is to visualize whatever the variables that you declare here in the things. So first the procedure is to create a thing. Now you can create a thing like LED blink. Okay, and you can add any number of variables, n number of variables, depending on the project that you choose. Here we are going to give the name for the variable. So I'm just going to give LED pin. I can say LED state, and you can choose the variable type here. Since it is on off type, I'm going to choose boolean, which means you can either have 0 or 1 as the state. And we have to give the permission to read and write, because if you want to change the pin value to 0 or 1, we need write permission. If you are going to take only the values from that particular device, like for example if you have a sensor, you have permission to only read. You can change this at any time. And variable update policy is like how frequently you want to update the data in the cloud. So whenever the data is changed or the value is changed for the particular variable, that will be recorded if you give on change. If you give periodically, means it will sample the value, time sample the value will be stored in the cloud. For this purpose of LED on off, I am just going to update the policy like on change, which means if there is a change in state of LED, that will be stored in the cloud. Okay, so I am just going to add the variable. You can see this shows last value and last update. So it will show you when the data was updated and what was the value updated here. So immediately when I added this variable here, you can see there is a notification here where it will tell you that this variable is declared in my device. Okay, so this device, this variable is now can be connected to any device that is associated with your uh, physical device. Okay, so dashboard, you can build a dashboard. Just click build dashboard, and you can edit by adding any kind of widgets. There are several widgets available. So I just want to interface a switch button to turn off the LED and on the LED. So here I am going to give the name LED switch. So if I change the value of this LED switch, that should be get reflected in my physical device. So all this will happen through cloud. Now I just have to link this variable to the things that I have already created. So you can see that if you click on link variable on the right side of your screen, it will show you the things that you have created and which variable in that particular thing you have to associate with that particular thing. So I am just going to click this LED state and link variable. You can see that it is getting updated, right? So you can also change some settings like this. Whatever you want to configure, you can configure it and then give done. So now you can place this move this anywhere in the screen, and you can also see how it will look on a mobile platform also, you can see, right? So this is the desktop layout. If you want to move, you can move it like this. You can arrange it anywhere you want. Now I am going to give this dashboard. So my first dashboard, right? So the next step is to connect my physical device. So I just have to connect my physical device, which is an ESP32 module that I will be showing you in a moment. So this physical module that I have, I need to connect an USB cable at this point, and connect the same cable to the other end of the cable to the CPU. So now I'm just going to connect the CPU. Before that, I would like to show you how the devices manager is responding for that. So here in this device manager, for opening the device manager, you just have to give start and type device manager. Okay, so you will be getting this. If you click on enter, you will get displayed on about this, and you have to click on ports. You see that there is only one device connected, which is all an inbuilt device in my computer. Now I'm just going to connect an external device, that is ESP32 module, using an USB cable to the computer. So you can see that the device manager gets refreshed, and I am getting a new device here, Silicon Labs CP210X USB to UART bridge COM4. Okay, this COM4 is the port through which my computer and the ESP32 module will communicate. Okay, so you can see the properties of it. Port settings, it is 9600 bits per second. It is called a baud rate, which you will be we will be using it in our program. So this driver you can get it free of cost from the internet. So if you just give Silicon Labs CP210X, you will be having this link, first link, and go to downloads. You can just download the universal driver and install the driver. Okay, now coming back to this devices, as I have connected my ESP32 module, you can see that ESP32 module has powered up, and I'm just going to add the device. Okay, now I have to choose the type of board I'm having a third party board, so I'm just going to give third party, and I need to select the type of device I want to configure. So I am not having ESP8266, I am having an ESP32, so I'm just going to give that. And then I have to select the model, so ESP32, if I type, I will get ESP32 module. ESP32 development module. So this is ESP32 development module, and then I have to click continue. Now I can give a name to the device because I just want to ensure that different devices have different names. This cloud device will automatically suggest a name, like it is a robot, so you can name your own robot. Okay, for this project I'm just going to give uh, smart switch. Okay, and then give next. It will automatically create this key, and I just have to copy this code and save this as a PDF, download the PDF and store it in some place, and then I have to click I have saved my device ID and secret code, and then click continue. Once it is done, we are ready to configure the smart switch. Okay, so you will get this kind of notification. Now it shows the status as offline. Okay, because it is not associated with any Wi-Fi devices. Now it is time to associate my things to this particular device. Okay, so associated device, it says it does not have any, so I need to set up associate this ES smart switch to this particular things, LED blink thing. So I just have to click and associate. When I give associate, it shows that the device, so it shows that you need to configure the network. The things is associated with the smart switch device which I have created already. If you want to detach this device from this things, you can detach it at any time you want. Okay, now it is time to configure the network. So I'm just going to give a hotspot connection for my ESP32 module using my mobile phone. Now I'm configuring this and the Wi-Fi name is, you just have to type any Wi-Fi name that you have. And here is the place where you have to paste that secret key which you have copied. So my might have downloaded the key, right? So that you need to open and copy this if you have not copied. This is why it is very important for us to download that PDF. Now you just have to paste it and click save. Now you can see that the device is ready to get connected, and I have turned on my hotspot connection. Now this device will automatically get connected. So you will be able to see this status offline or online. Once the ESP32 module is connected to the Wi-Fi, you will be able to see that the status will be changed to online. Then we can write the program to the device and observe the changes that you want to do. So I am just going to wait for some time to the ESP32 device to get connected to my Wi-Fi. Right, now it is time for us to write the program and check whether the device ESP32 is behaving as intended. Okay, so what is the objective here is, if I change the state here to from on to off or off to on, that should get reflected in my ESP32 module. So it is done with the help of IoT. Now I'm just clicking on things, click the variable and then go to sketch on this tab and then open this code in full editor mode. Once you open this code, you will be able to see that there are devices. Now you just have to click. If you have not configured it already, you can see that this module, I mean, you can choose the board here and search ESP30 ESP32 DEV module. Okay, and then choose the upload speed and all, etc. Right, all these things you can do. Since I have already set up all the settings, I'm just clicking on this. Now the device is ready to get connected. Now it is time for us to write the program. You can see that this is the default program which will be generated by the tool itself, the Arduino Cloud tool itself. Now you can define the LED pin variables and what should be the circuit behavior and all in the loop function or this other function that you have. Now it is time for us to see how to control the LED. So to control the LED, I need to tell to which pin of the ESP32 module my LED is connected. So for that, I'm just going to use a variable which is int. Remember that the variable names and the data types are case sensitive. So all the things that you use as small or capital letters or small letters, that should be followed throughout the entire design of your program. So LED pin is equal to 2. Okay, so this is the second pin, that is if I define this value is equal to 2, it addresses GPIO2 of my ESP32 module. As you can see in this image, GPIO2 that is denoted as D2. So I am going to represent that digital pin 2 as my variable name. Okay, so here the value is 2. If I give 4, this D4 pin will be addressed. If I give 6 or 5, this pin will get activated. Okay, so that is the difference. Now LED, I am going to connect it to the D2 pin because this inbuilt LED is also always there on the board, so I don't need an additional LED to be connected to the pins. So I will check only this switches, this LED is turning on or off. Now it is time to declare that the second pin, whether it is input or output. So for that purpose I am just going to write another command in the setup function. This setup function, this Arduino, it has two basic functions. One is setup and the other one is loop. This setup is used to give all the initial settings for the program to start, and loop is the one which is going to run continuously, which is embedded system is a infinite loop program which will continuously run forever to declare that the particular pin is output. This is the command we should use in Arduino. So we use the command pin mode. What is the pin we have defined? LED pin. And I just want this LED pin. I just copied the LED pin because I don't want to commit any mistakes from the variable name. Sometimes if I type, what I will do is LED pin like this, it will throw me an error. There is a mismatch in variable. If you are confident, you can just type whatever you have, and then I have to define it as output because LED is an output device. Okay, pin mode, that will be defined as output. Now I have defined the port pin as output. The next step is to assign value to the port pin. Okay, if I give the value is for this second pin equal to 0, the LED will be turned off. If I give the value as 1, the LED will turn on, because 0 represents 0 voltage and 1 represents 5 volts. This 5 volts will be supplied to the LED, which will make the LED to get forward bias, so the current will flow through the LED and LED will turn on. If I give 0 volts, it will not have sufficient power to turn on the LED, so it will be in turned off condition. Okay, so this should happen continuously. Since I am writing a digital value 0 or 1, I need to use the function digital write function, and to which pin I have to write? It is LED pin. So I am going to write LED pin, comma, what is the value I want to write? First, initially assuming that the device LED is turned off, I am just going to assign the value as 1 to turn on the LED, and then I need to give certain delay to observe that whether the state of the LED has changed. So I'm just going to write a delay function, DELAY, delay, and I need to assign some value. This value is represented in milliseconds. Okay, suppose if you want 1 second, you have to give 1000 here. Suppose you want to have half a millisecond, you need to give 500 as value here. Okay, so I'm going to give 2000. So what does that mean? I am giving a delay of 2 seconds. Now again I am going to write a digital write LED pin, comma 2, sorry, 0. So this will turn off the LED, and to observe that I am just going to give another function whether it has turned off the LED. Okay, so this command is to turn on the LED, and then this command is to turn off the LED. So this is what we have written. Suppose if you want to make whenever there is a change in the state of LED, you want to update in store the when that change has occurred, you can also do it using this variable. But for turning on and off, it does not require any representation. So I am just going to upload this code to my device. So you just have to click upload and save. automatically the device will upload the content to my board. So until then it will be showing busy. So now you can see that the program is getting uploaded to the device. So now you can see the status of the data, status of the upload. Once the program is uploaded 100%, it will automatically reset the ESP32 module. So you can see that it is by default turning on and off. Now it is time for us to control it through the cloud variable. Here we are not having any control, we are just writing the value continuously for after 2 seconds, 0 and 1 alternatively. Now I just have to modify the program slightly in such a way that it accepts value from the cloud and change the LED state depending on the input that I am going to give. Now we are just going to modify this same program using the simple technique if else statements. So I have the variable LED state. Depending on the value which is assigned to this particular variable using the dashboard. So I have connected the dashboard here. If I click 1 here on here, that value is to be updated in this variable LED state, and that value is to be written to my device. That is what is the objective. So this variable is to be written to the output pin. That is the objective here. For that I am just going to remove these commands and go to LED state change function. So whenever there is a change in this function, so I have removed the code from the loop statement and moving to this LED state change. So this function will be executed whenever a new value is received from the IoT cloud. So it represents this variable. If the value is changed from true to false or false to true, this function in my Arduino program will be running. Okay, so the value is available in the variable called LED state. Now it is time to write the digital pin, digital write, and to which pin I have to write the value is LED pin, and what value I am going to write is LED state. So I just have to check whether the things.properties.h is there. You can see this variable is declared as boolean in my function. This is an additional file. You should not change this function. You just can verify whether the variable name is same. LED state is here and I'm just using the same name. Okay, now it is time to upload the code and check whether it is working or not. I'm just have to upload the code. Now again the programming has compiled, you can see here, and the upload has started. The upload cycle, once it gets completed, it will reset the device ESP32 module, and we'll be able to observe the changes in the device. Now the program is about to get completed. Now it is having a reset pin. You can see that the cloud value, it will get connected. You can see that in the monitor. You will be able to observe once the device is ready to communicate or not. You can see that connection to this device is failed. It will retry for several times, and once it gets connected, you have to click on this monitor button. You will be able to see this, what is the status. Once the device is connected, then you can observe the changes. Whatever that you make here, it will be updated to the device. So every 4 seconds it will continue to. Now my hotspot is connected to the device. Now you can see that by default it is showing me one value, that is the LED is turned on. As you can see that the last update value is true, because in the dashboard, I'm just going to show you the dashboard. In the dashboard I have set the LED switch in on condition. Now I'm going to change this switch to off condition, and immediately it will get reflected in my device. I'm changing on, turning off, turning on, and turning off the LED. This is how you can connect the uh, devices and control the devices using a digital switch, digital pin.